It says for the figure below, find all interior angles of the triangle and express the results in degrees and radians. Okay, so what do we have in this figure? We have one triangle here and one triangle right here. So what can we do? The first thing to do is identify which angles do we need to find. Okay, so we need to find this angle, this angle, this angle, this angle, this angle, this angle, and this angle. Okay, so applying the concept that we learned at the beginning of this lecture, that it says that inscribed angles that intersect the diameter of the circle form a 90-degree angle. And what is the diameter of this circle? AB. This is a diameter. So let's identify the angles that intersect the diameter. It will be C, right? Because C is formed by a line going to B and a line going to A. And D, because this D is formed by a line going to B and a line going to A. So with this theory, we already know two of these angles. We know that angle C is 90 degrees and angle D is 90 degrees. Okay, so if we to move on to the following angles, if we look closely to this intersection, we can see that we are in front of a case of vertical angles, right? So what does it mean? It means that if we have 120 degrees at the top, we have 120 degrees at the bottom. And adjacent angles are supplementary angles, which means that they are 180 degrees. So this ends up being 60, because 60 plus 120 is 180. And this is also 60, right? Okay, so what other information can we gather? Okay, so now we have this triangle right here. We can calculate this angle, right? And with this triangle right here, we can calculate this angle. Remember that 50 is all the way. We need this small angle. Okay, so let's see. We can say, let's work first with this small triangle. And let's set up the equation. Remember, the sum of all internal angles of a triangle is equal to 180 degrees. So it will be 60 plus 90 plus, let's call this angle x, plus x is equal to 180 degrees. And x is equal to 30 degrees. Okay, so this is equal to 30 degrees. Now let's see, let's solve for this entire angle. Let's solve for this entire triangle. Let's solve for this angle. Let's call this angle y. And let's set up the equation. It says that 60 plus 90 plus y is equal to 180 degrees. And we have the same situation, y is equal to 30 degrees. This is equal to 30 degrees. If this angle is equal to 30 degrees, this has to be a number that added to 30 degrees ends in 50, which is 20, right? Because 30 degrees plus 20 degrees, we end up in 50 degrees, and 50 is given already. Okay? And finally, the angle missing is this one right here, right? But we have a triangle here, and we can set up another equation to solve for that angle. Let's call that angle W. And the equation will be 20 plus 120 plus W is equal to 180. W is equal to 40 degrees. Okay, so this is equal to 40. 40 plus 120 is 160, plus 20 is 180 degrees. And we have all the angles. Now we have to convert all these angles to radians. Okay, so let's make a list here. We have 30, how do we convert it to radians? We multiply by pi divided by 180 degrees. And this will be equal to pi over 6. Other angle that we have is 120 multiplied by pi divided by 180 is equal to 2 pi over 3. What other angle do we have? We have 40 pi divided by 180, and this will be 2 pi over 9. And if I'm not mistaken, we have 20 times pi divided by 180, which is equal to pi divided by 9. And finally, we have 60 times pi divided by 180 degrees. And this is equal to pi over 3. Okay, so this A looks very bad in here. Okay, so with this, we already solved for all inscribed angles, and we converted everything to radians. So let's move on to more exercises.